Yeah, it's been really hard to predict.
Yeah.
And so, I don't want to put my own money on it. Right?
Yeah.
But what I would say is I think that over the next couple of years, we're going to see the hype die down a little bit. I don't see how we can sustain the level of hype when AI is as expensive as it is and it's not producing the amount of money that it needs to.
Yeah.
Scaling is over, I think, in the sense that we are fast reaching that plateau. All the papers I've seen that show these trends are showing a plateau. Occasional papers come out that show there isn't a plateau, and you think, well, but then you look at the kind of way they've structured the problem, and it's like, well, there isn't on this one specific problem, and I'm unconvinced it's a general trend. My gut tells me that large language models will be a performant but not an overwhelming tool in the landscape of machine learning tools, right? In a 5 years' time, there'll probably be some new flashy technology that someone's invented, which is the next big thing. And in 5 years' time, it will be another different thing, and so on. That's how progress works.
Hey everyone, it's David Bombal back with the amazing Dr. Mike Pound. Mike, great to have you back on the show.
Thanks for having me back.
Yeah, Mike, lots happened in the last year. It's been too long since we last spoke. Things have been happening in AI. Perhaps you can give us an update and like a reality check of what's going on.
Yeah. It's been another really rapid advancing year with a lot of stuff it's very hard to keep a track of. And what's true, what's not true, what's going on, what's the dominant thing in AI now today but wasn't there last year, and so on. It's been quite a busy year.
So, Mike, I want you to separate the hype versus what you're actually seeing because you work in this field. I've heard on the news many things like it's a bubble. So perhaps we can start the elephant in the room, right? Is it a bubble, or is AI going to change the world like a lot of people are predicting?
It's definitely a bubble, right? Like as far as I'm concerned, but that doesn't mean it won't be a transformative technology anyway, right? So let's talk about the bubble first, right? So the reason people call it a bubble is because there's a small number of companies that are dominating AI, and when we say AI, we're really talking about the large language model chatbot agent space, right? Rather than the kind of normal AI that perhaps I do for my job day to day. And there is an inherent vested interest for those companies to want everyone to be excited about AI all the time, right? It's just like how if you're a car manufacturer, you want everyone to love your cars and be excited about owning your cars, right? It's not rocket science to think that those companies have a vested interest in it being exciting, right? But that doesn't mean it isn't in some sense exciting. Right? So, I use AI, right? I do AI for my research. I've used large language models. I've trained large language models. Not to the same scale, I should add. And so, you get a good picture when you actually use these things of what works and what doesn't work. Yeah. And I think that where we are is that the technology is unbelievably impressive, but not as impressive as perhaps you might claim if you work for a major company whose stock price is inherently linked to that.
Yep.
Right? And so, where I'm sitting, it's very cool technology. It does some unbelievably impressive stuff. But do I think we're all going to be out of a job next year? No, right? I don't. Because I'm fairly comfortable. There are companies in the news that are laying off people in favor of AI, but the numbers of people they're laying off might sound big on paper, but are actually not that large percentage of their workforce. And we're in a kind of strange economic environment anyway, where companies are being a bit reticent to hire, and it's unclear that that's directly linked to AI, in my opinion. It looks just like people are just taking things a bit easy on the hiring, rather than people are making a gap for this kind of agent that's going to come in and solve all our problems. So I guess I'm waiting and seeing, right? Like I've been doing for a couple of years. Right? But my general opinion is unchanged, which is that it's a great technology. It's very, very cool. We're putting too much faith in it, right? And we need to just kind of take a step back and see, what does it do? What does it not do? And we can make informed decisions about how we use these things.
Yeah, you mentioned this term agent, and you mentioned LLMs. And AI. It seems like AI, when people think of AI generally, people think of LLMs, but perhaps you can demystify that. What is AI? And because you say you do certain things, and then we've got LLMs, and then we've got agents. Can you demystify it a bit and tell us what's important in 2026?
We've used large language models in our research from time to time, but our research is not dominated by large language models, despite the fact that they dominate most of the media in terms of AI. You can kind of think there's kind of different levels, right? So you've got at the bottom, you've got machine learning. And machine learning is teaching an algorithm to do something, right? Usually not something particularly sophisticated, but machine learning can be, quite a small model, like a sort of support vector machine or a small neural network that does a very simple task.
Yeah.
It can be a big convolutional network that does a more impressive imaging task, or it can be some large transformer that does a really impressive large language model task. But they're just different scales of a very similar technology. And the what's actually happening in reality is that lots of these technologies get used, right? So we've got a project looking at hyperspectral data, which is data where you've got not just red, green, and blue, but maybe 800 different colors that you're trying to sift through. And to be honest, we found that very simple machine learning works much more effectively because it doesn't overfit so easily. Yeah, so we found that, standard machine learning works absolutely fine, right? And so why would we use a large language model when we already have something that works?
Yeah.
And that's actually true of a lot of problems. So if you're doing recognizing things in images or predicting the shape of things in images or trying to sift through MRI scans in a hospital, an LLM is probably not the right technology for you because that isn't text, right? It's images. And yes, we have this multimodal AI that everyone talks about, but in practice, actually, a supervised convolutional network or something similar will work very well. And so that's what most people use. And so actually, the stuff that's being embedded into hospitals and being embedded into microscopes is commonly not a big chatbot, right? Those things are being tried and being used, but for other tasks. So it's about choosing the right tool for the job. So you've got the AI that everyone talks about in the media is almost always large language models because they're the exciting thing you can talk to and they can write code for you and they can do all this exciting stuff. If you have some images you need to analyze, you don't use a large language model, right? Almost ever. Right? They're very inefficient. They're hard to train. They probably don't do what you need anyway. Just train a normal network. So I think the media and some of these companies have got overexcited about large language models. In fact, actually, you could say that the whole of the research landscape has got quite overexcited by large language models.
Yeah.
I mean, if you look at the number of papers that are coming out in the main conferences and journals in my field, dominated hugely by large language models. And I would argue large language models that are being used for things where it doesn't seem appropriate to use a large language model. It seemed unnecessary. It's computationally inefficient to do this when there was something that could have done it pretty much the same, but much more efficiently. And so I think we need to get to a point where we know which tool we should be using in which circumstance, right? And we have, I think in the last year, taken some steps towards this, right? People who are perhaps less excited about the idea that large language models are going to solve all the problems and are just using normal machine learning for other problems. And I think over time, we will come around to this idea that a large language model is something that is very good at manipulating text. So when that's your problem, it's great, right? And when that's not your problem, put it over there and do something different.
So you mentioned this term agent. That's also an AI thing, right?
Yeah. Agents are this idea that we are giving large language models more autonomy. Right? So, if you go onto the ChatGPT or the Gemini website and you type it, or Copilot, and you type in, a question, what's happening is you're instructing the LLM to parse that text and then give you a response. An agent is much more a system where you take a large language model and you allow it to go and find its own data and ask its own questions and talk to a different large language model that's doing something else. And the idea is that it's more autonomous. So maybe instead of asking a large language model to write a small piece of code for you where you're quite explicit about what code that would be, you actually say, I just want this whole website. And it goes off and it talks to something that produces some code or something that produces some XML, or some HTML. And, it asks all these questions. And then it comes back to you half an hour later with a much bigger response that's taken lots and lots of large language models, lots of different numbers of cycles to actually produce. Right? And, if you took this example to its extreme, you could imagine a situation where you don't do anything. Right? You just say, I want this thing to exist, and it goes off and it ferrets around for a day and comes back with a result. How close we are to that, I think, remains to be seen. Right? And there's lots of fun examples online of where an AI has accidentally deleted someone's entire database backend, right? Because it's gone too far. So we're bumping up against this, this limitation of how accurate are these LLMs? Are they accurate enough that you can give them full autonomy, or do we still need a human in the loop?
Yeah, because I mean, we like a year or two ago, like ChatGPT chatbots were the big thing, right? But it seems to have morphed in this year into agents, and everyone's talking about
Yeah.
agentic AI, and we're going to lose our jobs because these AI agents are going to take over. What's your take on that? Pessimistic, optimistic about it?
I think that the use of agents is a natural extension of the use of chatbots, right? Why do I keep going and asking the next question and the next question and the next question when we could frame this as I have this big overall goal and you can go off and ask these questions yourself and come back to me with a full response, right? And it's, maybe it's another natural extension also of this kind of chain of thought idea that large language models are using, where they go off and they think to themselves for a while and produce all this narrative that they're talking to themselves and then come up with perhaps a slightly better answer is the idea. In practice, the same limitations of LLMs still exist, right? So they aren't perfect. They sometimes hallucinate. They can go wildly wrong if they get the wrong kind of prompt, particularly a malicious prompt. And so you still got this idea that if you're not there specifically telling it what to do, there's a chance it will go off and do the wrong thing. And so it might be, but that doesn't matter because your use case is unbelievably straightforward, right? Maybe I give it a PDF and I ask it to think for a while and come back with a summary of this PDF, right? Perhaps I'm not happy with the summary. That's not great, but it's also not a disaster. But if I'm implementing a website and it's got root access to a bunch of my machines and misuses that root access, that's a much bigger problem, right? Or it's controlling a self-driving car, which is basically why we're not putting LLM agents at the wheel of cars, right? Because that would be unwise at the moment.
And what are MCP servers? Can you explain MCP? And because that's related to agents, right?
MCP is a protocol that's been developed by Anthropic. And in some sense, it's really just a common language form for communication between different agents. Right? And it allows you to bring these things up much more quickly, right? Rather than having to carefully parse the output of one agent into the input of the next and all this kind of stuff. It's got a much more plug and play. You can much more quickly develop these, what we might call like an agentic workflow, where you're telling this large language model to do this task with the help of these ones, all these extra tools and things like this. When a large language model actually has to solve a problem, it's not usually doing it on its own.
Yeah.
It's usually doing it with data sources and with web search enabled and with access to your files and things like this, because it can't guess those answers.
Yeah.
And typically the output will be much better if we give it live, real data. And so these technologies are just a way of streamlining this kind of process. So instead of having to spend loads of time writing very, very careful code that carefully prepares the input to a network, runs it, carefully parses the output, a lot of this kind of becomes quite easy, using libraries.
So what do you think is the future? I mean, because like we started with chatbots, we've got agentic AI now. There's the MCP servers are all the rage. I mean, we must have a whole conversation about cybersecurity because I mean it's a nightmare. But before we get there, we can do that as a separate topic. Where do you see this going? I mean, is it going to iterate into more like a better LLM? They just going to scale up?
It's been really hard to predict.
Yeah.
And so, I don't want to put my own money on it. Right?
Yeah.
But what I would say is I think that over the next couple of years, we're going to see the hype die down a little bit. I don't see how we can sustain the level of hype when AI is as expensive as it is and it's not producing the amount of money that it needs to in order to fund that. Right. And so, if you're buying hundreds of millions or billions of dollars of hardware and server farms and things, you need to bring in a lot of monthly revenue from customers. So that needs to happen pretty soon, right, if we're going to be able to keep this going. So, if let's say, just for the sake of argument, that it does die down a little bit, then what we're going to see, I think, is what happens with the rest of machine learning, which is it becomes a tool that is used helpfully in lots of workflows, but it doesn't become this tool where we can just replace our entire workflow, right? So I've got, a big document to write that's really important. I'm not going to probably be able to say to an AI, go off and think about this for 2 hours with a bunch of other large language models and come back to me with the full document. It's going to be more, I want this paragraph written. Can I have that, please?
Yeah.
And just kind of more practical, small chunks, I think is where we're going to go, right? Now, I could be wrong. Someone might figure out a way of creating agent systems that are much more robust, right? But I haven't seen it yet. And I think that I haven't seen any real strides in making, like the number of hallucinations drop to a level where we would consider it really safe, right? Which will be sub 1%, I would say, right? Because if you're running a large language model for multiple hours, it's going to make lots of mistakes if the error rate is too high. So yeah, I think over time, as the hype dies down, it will become just more of a practical tool that gets used. And my hope is that the research community starts looking at other technologies that could help large language models at the specific things that large language models are not good at, right? So things that are not text, for example, we need to keep researching into those things. There's also going to be, I think, a big push towards things like physical automation, so robotics, things like this. Robotics is unbelievably difficult, right? Just as a general sort of rule, getting something to walk around is much, much harder than getting something to recognize a cat in an image, right? It's just very difficult. And there's so many moving parts. And so things like self-driving cars, which are working in certain locations in a kind of semi-controlled environment, rolling them out globally, for example, is a huge challenge. And I think there'll be a big push towards that kind of stuff over the next few years, because those are things that actually would have a kind of transformative impact. I mean, if you could replace yourself as a driver, you can get a couple of hours of meetings done while you're on the way to someplace, right? That's a huge win, but we aren't there. So a lot of research has to happen between now and then.
I think the big concern is, right, in the news we get all these news reports that jobs are going to be taken away, AGI is going to come, and everything, we're all going to be replaced. And then the concern is, firstly, I mean, you teach computer science. Is it worth even learning programming? What's your advice to people like in 2026? Is it even worth learning to code? Because we've got vibe coding. I'm throwing a lot of stuff at you, but I just want to try and get your opinion about, should I learn AI? What should I learn in AI? Should I learn robotics? Should I learn computer science? What should I do, Mike?
Let's break it down, right? So, I mean, first answer is you absolutely do need to know how to program, right? Like, I think this idea that we're going to have autonomous agents to write all our code for us is just not plausible, right? It makes too many mistakes, and also customers are not going to want to use a system where a human hasn't looked at it and gone, that's actually correct, right? We're not going to give away all your data. And so you have to ask yourself, right? Suppose you work as a software developer. Let's say put someone who's watching, put themselves 5 years in the future, right? You've learned to program, you've learned to vibe code, one of these two things, and you're a software developer. Which of those two avenues gives you ownership of the code you're writing and allows you to be accountable for the actions of your code in a company where you might be making decisions on people's credit or banking records or banking transactions, right? So the idea that we can just automate that process, I think, is not plausible. Like, it's not reasonable to do that. Much as, I mean, I actually, for what it's worth, I'm biased because I like programming. Right? I've always enjoyed it. So I'm not the right person to ask.
No, but I mean, you deal with young people, right? And I mean, it's a concern, I'm sure, that they raise with you.
It's a huge concern, right? It's a concern because they're worried about jobs, but it's also a concern because you can use an AI to try and get yourself through a degree, right? So suppose you're at college or university and you've got 3 years of programming assignments and exams ahead of you, right? It is likely that careful use of AI that no one notices, and I'm not advocating for this, by the way, would help pass some difficult programming problems. If I give someone a difficult programming problem and they work with an AI, they might find that problem easier. The problem they have is when they have a 6-hour programming interview for the job at the end of their degree, right? You need to be able to code in order to pass that interview. And you're not going to be able to do that if you phone the most challenging part of the learning process off to an AI. If you get stuck on some code, right? I mean, I did a recent video on memorization, right? Which is this programming concept.
On Computer Farm. I'll link it below.
Yeah. And suppose I just said, I want a memorized step counting algorithm, and it gave me one, and I submitted that, and I never thought about it again. Do we think I'm going to be able to do that in a week's time? I'm going to be able to rewrite that algorithm myself. I'm going to know and understand how that process works. It's not reasonable to think that. So I think that how people should be using AI in an education space is using it to help augment their learning, right? So I'm reading this paper, let's say, and I'm stuck on this formula, right? I don't really understand what they did here. Why have they transposed this matrix, right? Maybe I'm not a huge expert. As it happens, I'm not a huge expert in linear algebra. And putting that into a large language model, it might give you that piece of information that you need much more quickly than a sort of random web search allows you to find the kind of first principle, of this formula. But what I won't do is just put the PDF into a large language model, say, can you code that up for me? Great. send that off. And now I don't understand how it works. I don't understand how my code works. I understand nothing about the situation. And I mean, I'm maybe the worst example because I'm an academic and sort of my whole job is to learn more things, tell more people more things. But I think we run a risk as a society of offloading our learning to some machine and then we all don't know anything, right? And it's early days, right? I don't want to raise a panic, but you can see signs of people offloading things. And I think that's a very temporary solution to a long-term problem, right? If you want a job in cybersecurity or you want a job in programming or you want a job in AI, the best way to do that is to learn those concepts and become an expert in those things. And that takes, I'm afraid, hours of work and study. What you could do is get yourself, is sort of push yourself through some assessments by kind of using AI, but it's not gonna get you that knowledge. And so where this leaves us, I think, is you should still learn to program, because ultimately, if you're a software developer and you code something, you need to know that code is correct and it's going to work when it's deployed, right? You've got other people in your team and customers relying on you for this code. And so if you can't say, I know what that code does, I don't think that's a good thing.
Yeah.
Right. And so that kind of leads us a little bit perhaps onto vibe coding.
Yeah, well, that was my next question. Vibe coding is the future. Sorry, go on.
Yeah, right. In some sense, I've got no objection to vibe coding in the sense that there are certain things that it's a bit of a waste of time to code, right? So suppose I'm writing a bash script to sift through a bunch of files.
Yeah.
That is not my main research area. I'm not going to get a publication for doing that. I'm not going to get any funding or any kudos as an academic for doing this, right? And it's been a year, let's say, since I've written a bash script. I can't remember how to do it, right? So if I use an AI to do this, I read the code, I check it's okay, I make sure it's not doing everything with sudo, and there's a cybersecurity problem. I don't think that's a bad way of doing it, right? Even if I've barely written any of the code myself. And kind of vibe coding is along these lines. It's saying, I don't need to spend time. I already know the thing. I don't need to spend time writing this. I'm going to work with the AI to write it. And I think that's a good thing, probably, right? And it will make lots of programmers much, much faster. But if we take it to an extreme, let's suppose someone doesn't know any code at all and they produce this bash script that they're about to run as root on their Linux machine. They don't know what it does.
Yeah, exactly.
Right?
Yep.
And, they have to think carefully before they run this script, right? It's a bit like when you bring a script off the web and pipe it straight into bash, right? Just maybe read it first. And so ultimately you have to know those things. And if you know those things, I think AI can be a real help. If you don't know those things, I think you take a tremendous risk. And so it kind of ends up with that question of, are we all going to lose our jobs? And I think the answer probably has to be no, because someone needs to know how this works, because otherwise we're just going to have bugs everywhere because the vibe coding didn't quite do what it was meant to do and no one was there to just tweak the output and fix it. And so I think a better question, I guess, would be, is it going to lead to some job losses, right? So maybe let's imagine that a big software company hires 1,000 developers, right? And they have 1,000 developers doing work for them. And let's imagine that AI makes those developers a bit more efficient. They can now get away with 900 developers, right? That, I think, is a more plausible kind of job loss scenario where someone finds a way to make an AI more, to make everyone a little bit more efficient and so hire fewer people. In actual fact, I don't know from your point of view, but I find that the more efficient I get, just the more work I get asked to do. So in actual fact, I think it might be that they just increase their output and hire the same number of developers they always have and make more profit, right? I mean, that seems a plausible output as well. So I don't think there's any guarantee that, there are some companies trying this. They're trying to lay off people and replace them with AI. There are also very good examples of where that hasn't worked, right? Replacing tech support with a chatbot that ended up being extremely rude to a number of people and things like this. So companies that are firing people now in the hope that AI is coming along in a couple of years' time, they might be making a mistake because they need to get those systems in place first before they start undermining their workforce. But I think, I don't think there's an immediate risk of large scale, changes to the way we work. Right? The other question that's really difficult to answer and everyone disagrees on is exactly how much more or less efficient we get because of AI.
Yeah, it's a good point.
So I have been programming for decades, right? And I do machine learning all the time. And so if I use AI to, let's say, answer trivial bash questions, that probably does make me faster, right? Because it's not a good use of my time to go off and learn about those things. But there was a really good study last year that evaluated very senior software developers and their ability to add features to an established code base, and they found they actually got slower.
Yeah,
right?
interesting. Yeah,
But they thought they got faster.
Yeah,
right. They perceived that they got faster because I guess when AI writes 1,000 lines of code just like that, it seems so efficient, right? But of course, the amount of time they spent sifting through it and fixing things and changing things ended up actually being slower overall. So your mileage is definitely going to vary depending on your experience, depending on the thing you're writing, how trivial it is. But this idea that we're by definition all going to get 10, 20, 30, 50, 100% faster, I don't think there's any evidence of that yet, right? We're going to see more papers coming out over the next few years. I think we have to wait and see. I think it's too early to say no one's going to lose a job. And it's definitely too early to say we're all going to lose our jobs, right? And so we're going to be somewhere in the middle.
Okay, Mark, so you've convinced me I should do computer science, perhaps a traditional degree. I should maybe learn AI. So, I mean, you in both those fields, cybersecurity. So I want to get into cybersecurity. We'll probably do that as a separate video. So I'll link that below because that's a whole can of worms, I think. But what's your advice? In the past, you told me to learn Python. You told me to go and get Andrew's course. Can you sort of give me a roadmap? Like, what should I do? I mean, I'm assuming traditional computer science has changed a bit with AI, but it's very much the same thing. But like, if I want to get into AI, computer science, what should I do?
I mean, so let's talk about university and college, right? So obviously I'm an academic. I'm going to advocate for people to go to university. There are fees, and maybe not everyone is in a life position, like maybe they're a bit older. They're not particularly interested in going back to university to change course. And I can understand that. I mean, it happens. We see mature students, and that's great. I think it depends on what kind of learning experience you want, right? It's perfectly possible to sit at home watching Udemy courses and watching, O'Reilly courses and watching all these Coursera courses and pick up enough knowledge that you can start to get started. You can get going in this field. But you obviously have to have a lot of self-discipline to do this. You have to be sitting at home. You have to be spending hours doing this. A bit like if you're going to learn a musical instrument, it's unlikely you're going to be able to do that just by sitting about. You're going to have to put some hours in. But it's possible. Right? What I think a structured degree or a course gives you is kind of experts who said, these are the things you need to learn in this order. Right? And so it's someone like holding your hand a little bit through the process of what you learn next. Okay, you've done that. Now what do you learn next? And you get that assessment that says you have learned this thing. You're doing great, right? And keep going. And then at the end, I guess you also have, certificates and things that give some evidence to an employer that you have those qualifications. But it would be wrong to say that it is impossible to learn these topics elsewhere because, of course, that's not true. You definitely can. So I think people have to make that decision based on their own personal, situation. Things like this. In terms of what you need to learn to get into AI or cybersecurity, I think a good grounding in computer science is always a good thing, right? So cybersecurity, for example, we're finding, I think, just in general in the technology sector that people have less knowledge of, let's say, underlying file systems and the structures of Linux and Windows than they used to, because ultimately we're not exposed to those things quite as much as we used to be. Your smartphone hides away how it stores all the files. It's actually quite hard to find files in the traditional sense on an iPhone or an Android phone. They are still there, but you don't see them. And that means that, you might approach a degree or you might approach some of these courses outside of a degree, not absolutely knowing, how you administrate a Linux server, right? And that's going to undermine your ability to do cybersecurity. And it's the same thing that's true of machine learning. So to do machine learning, you need to be able to write some code. It's not probably in general as advanced as code you might write, let's say in C or Java for some bank. It's, I think, easier to train a neural network than it is, for example, to implement AES without any kind of problematic weaknesses.
Interesting.
But it's not trivial, and you need to be able to understand this. And the other thing is, of course, if you make small mistakes, you need to be able to debug and find those mistakes, right? It's very easy in machine learning to put the data in the wrong place and you suddenly find you've undermined your ability to train the network at all. And, what are we going to do about that? Right? And you need to be able to find those problems. So I still think the path is somewhat the same, right? It's learn Python because Python is the dominant language for machine learning and is also a commonly used and popular programming language. It teaches you many of the things that we see in other programming languages, right? I'm not someone who gets particularly worried about one language versus another. if you say Python's the best language, you're going to get a lot of annoyed people.
Yep.
If you say Java's the best language, you're going to get even more annoyed people. Right? I'm very relaxed about this. I think you use whichever you need to use for your specific situation.
Agreed.
And ultimately, machine learning, that is Python.
Yeah.
For better or worse. So, if you know some Python, you're basically ready to get started on things like Andrew Ng's Coursera course, which will get you the fundamentals in machine learning. And I would do those fundamentals in machine learning first, always. Right? If it's not his course, it's someone else's course in machine learning, because everything that a large language model does, everything that an agentic AI system does, ultimately is a big version of these smaller concepts. And knowing what those are is going to really serve you well when something doesn't work later, particularly because, as we've discussed, we're not absolutely sure what the dominant technology will be in 10 years or in 5 years. Even in a year, we don't know for sure that someone isn't going to change the game a little bit with a new kind of thing that we're all going to have to learn. It's much easier to learn those things if you understand everything they're built upon, right? And a large language model is something called a transformer. A transformer is a type of neural network. And a neural network is that same thing you learn in Andrew Ng's course, right? Which is just a very simple multi-layer neural network, right? And they're just bigger versions. So I still think that's the correct order, right? So then you can do your deep learning specialization. So Andrew Ng has a deep learning course. There are loads and loads of deep learning libraries out there. The PyTorch documentation is really good with its tutorials. I always encourage my students the first time they ever get their hands on machine learning to have a go at the MNIST example. Right, MNIST is a classic data set of handwritten digits published by Jan LeCun originally. And it's your kind of entry level, have you trained a neural network problem, right? Because you can get a CNN, a convolutional neural network will get about 99.9% on this data set within about a minute of training, right? So if you've done that, you're onto something, right? You've trained the network, it's working.
Yeah.
It's your validation that you've done it. Right? And then you can replace the network with a bigger one. You can replace the data set with a harder one. And before you know it, you're training all kinds of complicated networks. And if you want to have a go with something that I work on, which is plants, I actually have a Google Colab example of training a standard neural network on some plant classification, which is a good way to get, experience of all the different things that PyTorch does. And we can share that.
That's great. I'll put all the links below. I got to ask you this question, right? Is it too late for me to learn this? Because, AI is this huge thing. Is it too late to get into this?
No, I mean, it's worth bearing in mind that 5 years ago, we hadn't even got ChatGPT or anything like this. We had transformers, but they were just something cool in natural language processing, This idea that we're fixed doing the thing we're doing now, I think it doesn't hold up historically, right? I mean, in actual fact, when I started when I got my PhD, there was very little machine learning. There were no convolutional neural networks. They had been invented, but they were very, very, low key. And so I essentially had to change fields, right? I know a lot of sort of low level image processing, bit manipulation of pixels and things like this, edge detection.
Yeah.
I learned all of this from my PhD and from my research that was at that time. And then CNNs took over and I essentially pivoted over to machine learning and AI. If I can do it, you can all do it as well. I think that's fine.
You're a very humble guy, of course. Sorry, go on.
You just put in the hours.
Yeah.
Right? I've spent a lot of hours reading papers, a lot of hours trying these things out. I mean, if I appear like I know what I'm doing, it's only because I practiced a lot, right? It's not because I woke up one day and I knew how AI worked, right? That is not true of anyone, right? And anyone that said, all these people who sort of act like high and mighty about how they're so expert in these things, they just put in a lot of hours of practice, right? Just like with a sport, just like with any other field, right? And so I'm trying to learn the drums, right? I'm getting slowly better at learning the drums, but it's hours and hours and hours of getting it wrong before you get it right, and it feels really good. So same with AI, right? Just practice, you'll get better, and then before you know it, you'll be training some pretty deep networks. I mean, I think maybe we need to embrace the unknown a little bit, right? In terms of AI, I think that there are a lot of people telling us this is going to be the future, or this is not going to be the future. It's definitely going to go like this, right? And we're definitely going to have, humanoid robots in 5 years. Or we're definitely going to have self-driving cars in 5 years. And, you'll all be out of a job because we'll have invented this one thing that will replace you. And I've yet to see any evidence, right? I've seen some evidence that some things are good, right? But I haven't seen any evidence that all these things are going to come true. And until I do, I'm not planning to worry about it too much, right? I think that I just live my life, and I address the things that come at me like everyone. And so we don't know what's going to happen, right? My gut tells me that large language models will be a performant, but not an overwhelming tool in the landscape of machine learning tools, right? In 5 years' time, there'll probably be some new flashy technology that someone's invented, which is the next big thing. And in 5 years' time, it will be another different thing, and so on. That's how progress works. It may be that AI is completely transformative for humanity, like these companies are saying. And I think to an extent, we're already seeing some signs of this. So, for example, in healthcare and computer-aided diagnosis, the idea of trying to make doctors more efficient and faster and more accurate with diagnosis with the help of an AI, rather than replacing the doctor with an AI. That's a great thing to research. Protein folding, right? The idea of searching through potential proteins for health-related matters, or maybe looking for new antibiotics and things like this. These are fantastic things that we should be pushing as hard as we can. But we aren't about to not need any doctors. We work with the AI to do these things. And so that's kind of my take. I think that it's a really optimistic future. I think that anyone that says the thing that I'm doing is the thing that's going to replace everyone are way off, right? Or they've got a vested interest that we need to think about. So, you can listen to them or you can listen to me. I'm being friendlier, right? That's it.
Yeah, you haven't got money invested in this. You're not betting on like the stock price going up.
My research goes on, and if the dominant technology changes, so I use convolutional networks mostly, and sometimes use transformers, and sometimes use large language models. If, let's say, in 5 years' time, some new thing has been developed that's really, really good, I'll be using that, right? Absolutely. But I'm not worrying about it, right? And actually, I think that the researchers in core AI, so that, the researchers that work, because I'm kind of applied, but I like to solve problems with AI rather than, I don't spend as much time working on fundamentally changing the architectures. But the people that do would do well to try and find new and more and better approaches than just trying to wring as much performance as we can out of the approaches we have today, right? Which I think could lead us down a path where we're not making as much progress as we could.
Yeah, because one of the points we had here is scaling over, because it sounds like they have to change the way they do it, right? They can't just keep on trying to scale because we're going to run out of water, we're going to run out of electricity, et cetera, et cetera.
Yeah. The actual energy cost and the water cost of large language models is hard to know exactly, right? I mean, it's significant. Scaling is over, I think, in the sense that we are fast reaching that plateau. All the papers I've seen that show these trends are showing a plateau. Occasional papers come out that show there isn't a plateau, and you think, well, but then you look at the kind of way they've structured the problem, and it's like, well, there isn't on this one specific problem, and I'm unconvinced it's a general trend. Ultimately, I think this comes down to money. Right? If you want to make your large language model 10 times bigger or run 10 times more tokens through it to get the best answer, it's now 10 times more energy and efficient. And how much more performance have you got from that? If it's 10 times, that's probably worth doing, right? But if it's 1% better, and actually you'll find, I mean, none of your phones might use large language models to do various things, but a lot of the AI that phones are doing, like Face ID, for example, on an Apple iPhone, that is not a large language model. It's a much smaller neural network, because you can't plausibly run people's faces through a large language model at that kind of scale. It would be much too expensive and it wouldn't work. So we don't do it. So I think it's about being smart about when you're using these things and when you're not. The companies that are really pushing these tools, as I said earlier, are going to need to start obtaining a lot of profit in order to justify the amount of expense in training these models and in delivering these models, for free, essentially, right? Do I think maybe we lose the free tier of access to AI fairly quickly as it becomes prohibitively expensive? That could happen. Right? We might have to pay because they're too expensive to run if people can just around the world use them for free. When that happens, what number of people will still use them in the same way they are now? I don't know. So it's interesting. I think scaling is reaching an end.
Yeah, I mean, I talk to people like at Cisco, and they talk about just the network infrastructure to try and do this, and how big these data centers are getting. It's crazy how big these things are getting.
It's not feasible, the amount of money that's being spent on these data centers, unless similar levels of money is being brought in terms of productivity gains or GDP boost to a country, or, return on investment to the actual company in terms of, let's say, membership fees for an AI model. We're seeing plenty of people use AI, but we're not necessarily seeing enough people paying to use AI in the numbers and the size of the amount that they would need to pay to justify the cost of these data centers. I think the argument that the data center providers and the companies are using is we will be at that point in the future. Right? That is a big unknown. Right? It might be that in 5 years, I've been so embarrassed that I've left YouTube, because I'm so incredibly wrong about it. But it might be that AI is so performant that actually everyone kind of has to use it all the time, and then the profit's there. Or it might be it does kind of what it does now, in which case everyone kind of uses it how they do now, and the profit isn't there. And so where we are on that spectrum, I think, is not quite known. But there needs to be some money going in soon because of the amount of money being spent on these data centers.
Yeah, I think that's the concern about the bubble, right? You have these few companies that are investing in each other, and the money's going round and round and round. And I mean, the people are really concerned that it's going to pop. Go on.
The other thing is that you have to consider that the technologies that these companies are using are published, right? Now, their own models are not published, right? They're all proprietary. The data sets are proprietary. Like, Llama, which Meta produced, that's available for free. DeepSeek, trained in China, that's available for free. It's plausible that even if there was, such a demand for AI, you only need a few people to release very performant free ones that people can run themselves to completely undermine the business model of many of these other companies. And that's a sticky situation as well. So I think that the better AI gets, the more chance there is of a free one that everyone can use, which undermines the business model as well. So something has to give, I think, and we end up in a kind of steady state where AI is what it is, and we're all using it in a kind of normal way, but perhaps not at the scale we're using it now.
Yeah, I love what you said about like DeepSeek and other free options. And it gets me to the next question about like edge computing. I mean, do you see AI? You mentioned the iPhone as an example. Do you see AI running? Like, I think you've done this before. You run AI on your GPU at home. Do you see people just from a privacy point of view, cybersecurity point of view, or just cost point of view running it locally? Sorry, go on.
Yeah, I think privacy and is going to become increasingly important. Right? So we have a policy in the university of only using specific AIs that we trust. Right, we have an agreement with that company and we use them. But that's not how products work in some sense. Right, we've got 8,000 or so staff. All are autonomous people. Maybe they find some new tool that they really like and they want to use it. What are the rules about this tool? It's like, it can be unclear. And, potentially breaching, let's say, UK GDPR regulation by putting some personal data into a chatbot that you didn't realize was actually going off to the cloud, that's a huge risk. And I mean, the best thing to solve that risk is to kind of bring this kind of chat into your normal cybersecurity training that you run as part of your company. Right. So you have a company. We all have to sit there looking at pretend phishing emails, trying to remember which one's which. Now we have a little section on AI that says, just remember, don't put personal data into here because of what happens to it. Edge kind of solves that problem, right? So when I'm training something where, let's say, I'm using my personal emails, or I'm using personal data from, let's say, maybe you're training a medical AI, right, based on patient data. You either have to have an unbelievably robust agreement with the company that you're training it on, or you run your large language model locally. And what you do will depend on the sort of the scale of the problem you're trying to solve, bearing in mind that not all of us have the hundreds of thousands of GPUs required to train some of these models from scratch. But there are techniques to train them more efficiently. I suspect that's where we may go. The other thing is that you can't deploy the scale of these models on anywhere close to a mobile phone, right? So, NVIDIA released the Jetson Nano, great product. But it's still limited in scope compared to what some of these models are doing. And so we're talking about smaller distilled models that do specific tasks, which is kind of what AI has been doing for the last 10 years anyway. So I think that's a perfectly reasonable thing to do. Why do you need a chatbot that solves loads and loads of different problems when you have this one specific problem you're trying to solve on your smart doorbell, right? That you can just implement locally in an efficient way. So I think a lot of companies are going to focus on efficient, small-scale solutions to individual tasks because they will work better and they will work more cheaply, and they can better control, the hardware and so on. I think that's a good idea.
I mean, the privacy angle or privacy for my American friends is, because I always get, some people always like to comment on my pronunciation, is a big issue, right? Because, I mean, data is getting taken. I mean, I saw recently I think it's Samsung, some television is now running AI on the television, and it's just like AI is being pushed into every product. And from a privacy point of view, like what's happening to all our data?
It's that's an unknown, right? And it's not something I'm usually comfortable with. I think that the argument at the moment is if we embed AI in everything, that's where we get to the point where everyone ends up having to pay for it, and we'll, bears that profit we want. But ultimately, I think there are some tasks where you don't need AI to do those things. Right. Yeah. Certainly AI, but it doesn't work 100% of the time. That's the the big question.
Yeah.
I mean, let's suppose someone develops a self-driving car that's really performant, but it requires very expensive hardware to use. I'm paying like this much for a car. Do I want to double it so the car drives itself, or will I just drive the car? Right. Which I can do. I don't know is the answer to that. Right. I do want my naps in the back of the car, but I think it's an unknown. How much will these things cost? What sort of hardware is going to be required? I think we don't know the answers to these questions. And privacy is a big deal. I don't want the camera feed from my car going off somewhere.
Exactly.
Right? I mean, for what it's worth, I'm just sitting there doing nothing. Right?
Yeah, but still,
it's the principle of it, right? Yep. I think and actually, I'm not overly comfortable with video doorbells, particularly because I don't know where those videos are going. Right? Who's seeing them? How long they're there for? What happens if there's a breach? Right, and it's not necessarily to say that those companies are doing things wrong. Right, they might have incredibly good cybersecurity practice, but I haven't read any of the white papers. I haven't looked at the code.
Things go wrong.
Things go wrong.
Yeah.
Right, and so and then, and as we know from cybersecurity, this idea that nothing can go wrong, right, or something is unbreakable is absolutely it's just not true at all. We cannot know. And so with that in mind, the more data and camera feeds and audio we're collecting, the inherently more vulnerable we are to problems. So I, at the moment, am being somewhat resistant to kind of putting all these sensors everywhere and tracking everything I do, just because I don't know where that data's going yet.
Exactly.
Right? And when I do, maybe I'll change my mind.
No, I doubt
until then,
I doubt it.
I'm taking a little bit of time to think about it.
I mean, the whole privacy thing, it's like, why do they need to know so much about me? And I mean, where's my data going? And can that data be used against me? I mean, that's a whole can of worms in itself.
And the way that data is used has changed. So maybe a website exists to, let's say, provide an online shopping experience, but the website grows and grows and grows and starts offering other products, and then your data is being used in another way because the end user license agreement's been changed and you didn't see it. Right? It's a bit of a minefield. And because it's so hard to track, I don't think people are able to make informed decisions. Right? And bear in mind that I'm talking here to someone who runs a popular YouTube channel who is, knows a lot about networking and cybersecurity, right? And I know quite a lot about AI and cybersecurity. We're not, in some sense, normal run-of-the-mill people from the street who don't know any of these things and just click yes on stuff.
Exactly.
So, and those are the people that these we should be protecting, right? Because the people who are not experts and are doing other jobs. I've always felt that, like cybersecurity, for example, we digress away from AI briefly. Your job is protecting the people who don't know about cybersecurity. Those are the people that need the help, and that's who the products are for. So if you're just collecting their data and using it, I'm not so sure about this. Right?
Yeah, I think there's a lot of pushback against all this data collection because if something's collected at some point, it's going to get leaked. The data,
and it's happened so many times. You think, how could it happen again? Right? Well, because ultimately these are not perfect systems, right? Maybe someone's vibe coded the security backend.
Exactly.
And they're not perfect systems, and you can't guarantee anything. So you have to try and act in good faith as much as possible. And I'm not always sure with the data collection that is necessarily what's happening.
So, Mike, I want to ask you this: if you were starting today, or if you were talking to someone who wants, perhaps they're young, but perhaps they're older, they just want to do a career change, what would you recommend that they do? Like, would you recommend cybersecurity? I mean, AI, computer science? I mean, obviously you both and I, we have biases for certain areas, but like, where do you think the hot area is? Robotics? Because you mentioned robotics in this interview. Perhaps I should go and look at that. Sorry, go on.
No, robotics is a hugely big area, right? It's getting bigger. I mean, how many people can be realistically employed in robotics? I'm not sure, right? Probably not as many as AI because, you have to have access to all the hardware in labs.
Yeah.
But robotics is a really exciting place where we're going to be trying to build more complicated robots that can do more impressive things, particularly to help us with our everyday lives. It's so difficult to do, right? I can't, like, the roboticists watching will be like, yeah, it is, right? They'll all know because just everything is hard when you've got so many degrees of freedom, right? And your thing falls over. So, that's a hugely exciting field. I think it's going to be great. AI remains a hugely hot topic. And even if the bubble bursts and we end up in a situation where large language models are just a tool and we're looking for the next big thing, it's still hugely useful in medicine and in plant science and in self-driving cars and in all these technologies. Your phone, right? And, unlocking when you look at it.
Yeah.
All these things that we now take for granted are driven by AI. So that remains a huge field. And perhaps the biggest of all is cybersecurity, which is often hidden because by definition it sits behind just looking after things, right? But, if my experience of what the students are into, our third year undergraduates, our fourth year undergraduates who are about to graduate and go into a job, there are lots of people interested in cybersecurity careers because it's hugely exciting. You're making a real difference, and you can also gain quite a lot of experience on the job, right? Because of the way that you often learn by being exposed to these issues. I think they're all incredible careers. Cybersecurity, I don't think is going away anytime soon, right? Despite what people might have said, we haven't managed to fix the problem of all these leaks, right? And all these backdoors and all this stuff. So until we do, which we won't, there's going to be plenty of jobs. And just even kind of low-level system administration. So kind of keeping networks running and making sure your firewall is letting things in and not letting things in as appropriate. And the server is listening on the right ports, but not all the other ports. Stuff that we take for granted a lot of the time. I mean, the amount of computer systems we have now, it's more important than ever. Right? And none of this has been automated. There are interfaces to help you, but you still need a large number of people who have experience of networking and how we can secure things in order to keep things running. I mean, in Nottingham, we have a team within computer science looking after our local network, but we also have larger university teams looking after a whole network. And just the scale of the thing is huge, right? And this is a big organization, but it's not the biggest. And, these are not easy problems. And so I think that cybersecurity remains a really interesting place to be as well. And of course, maybe the best will be the interface between AI and cybersecurity, right? How do you keep systems secure when half of them are running autonomously and someone's gone for a coffee and is not watching what they're doing?
So if you were starting tomorrow, like a magic wand, you're 18 now. What would you do? Cybersecurity and AI sounds like the place to be, or robotics maybe.
I think so. I mean, it's difficult to know what I would do if I was back to being 18, apart from be less tired. I always thought that cybersecurity and cryptography were really interesting, but I happen to take a real liking to computer vision, working with cameras and the image data and things like this. And it's hard to see me changing my mind, right? If I went back to 18, I'd probably do that again. For me, AI gets you that thing, right? It allows you to, because most of the AI I do is on images. And so I get that part of my, of my passion, that, is part of my job. But actually, I think if I'd have gone down cybersecurity, I'd be having a very happy career as well.
Mike, as always, thanks so much for sharing. And thanks for being real. I mean, you're not trying to sell something. You're just trying to help us. And thanks so much for doing that.
No one's paying me anything for this. No, I'm not trying to sell anything. I'm really excited about AI, but I've got no vested interest, right? If we change our minds in a year's time and do something else, fine with me. Right? See how we go.